So now we're going to look at a table and find the average rate of change. So when we do that, first of all, it says we're going to find it over the intervals from x equals 0 to x equals 2. So here's x equals 0. Here's x equals 2. So what we're going to be working with is we're going to be working with 0, 5, and 2, negative 3. Here's x1, here's y1, here's x2, and y2. When we fill in our formula, then the change in y, negative 3 minus 5. Change in x is 2 minus 0. And we end up with negative 8 divided by 2, which simplifies to be negative 4. Use Desmos if you need help with that. If we look at part B, from x equals 1 to 4, so with 1, we're going to be using this value and this value. So 1, 1, 4, negative 11. Here's x1 and y1, and x2, y2. Change in y. Change in x. And we end up with negative 12, negative 11 minus 1. 4 minus 1 is 3. And negative 12 divided by 3 is negative 4. And it says, is this function linear? Well, if you notice, if I flip back a page, when we finished that one, we came up with negative 4. When we finished part B, we also came up with negative 4. Yes, this function is linear. If you remember from an earlier video, we talked about how this average rate of change or the slope is constant on a line. And what that means is that the slope is the same no matter what 2 points we use to calculate it. So that's the way we can answer it. How can we tell? The slopes are the same. Same idea as we look at this next one. When we take a look at it here, this time we're going to use the table to calculate the average rate of change from 0 to 2. So we'll be using those two values. Our ordered pairs then are 0, 10, and 2, 9. Here's x1, there's y1. Here's x2 and y2. Change in y. Over change in x. We get negative 1 over 2. Now, when I was making the smartboard file, I didn't copy down part B, but I added some in to help us. But look at your chart here. I will switch my highlighter color to try to help us out a little bit here. And what it says is that we want to go from 2 to 6. So I'm going to flip back here. So from 2 to 6 is what we're going to be using. And I have those already written in. We'll just check to make sure that I did them correctly. And I believe that I did. So when we take a look at this particular problem, then here's x1 and y1. Here's x2 and y2. And when we fill this in, then change in y over change in x. Well, 3 minus 9 is negative 6. 6 minus 2 is 4. If we type that into Desmos, we find out that we get negative 3/2. And when I look back here, we ended up with negative 1/2 on our first part, and we ended up with negative 3/2 on our second part. And then the question says, is this function linear? Well, oh, there's my 2 to 6, of course. It got hidden. But is this function linear? No. And how can we tell? The slopes are different.